Okay, so let's do this together. So I'm going to stop sharing this. I'm going to go to Desmos. What the? Oop, wrong button. All right, so we have that. All right, so let me get rid of this actually. So again, we have the two graphs to put in, right? We want to graph them, okay? Well, get out of here. Clicked Microsoft Word by mistake. That's why I said get out of here. So wasn't saying it to anyone. Don't worry. So anyway, we have negative x plus y equals 2. The other one is, what's the other one? 4x plus y equals 2. You can see they do intersect, and it looks like they intersect at 0, 2. I mean, you can always check by substituting, but it does look like they intersect at 0, 2. So, all right, that's good. All right, any questions on this? Again, when I said get out of here, I by mistake clicked on Microsoft Word, so I wasn't speaking to anyone. I hope no one thought that. So, hope no one did. All right. All right, let's go back to the notes then. There it goes. All right, so again, that's the graph you would get. I mean, the colors of the lines were different, but, you know, still the same line. So here's another one. Here we can solve it by substitution and then check it by graphing, you know, in Desmos. From the first equation, this one's a little bit different because I know you're, maybe by habit, you're getting y in terms of x. But from the first equation, it might actually make more sense to get x in terms of y. And why is that? The coefficient of x is 1. Okay? The coefficient of x is 1. So that's why, to me at least, it makes more sense to get x in terms of y. I mean, you could get y in terms of x if you want to, except you'll be dealing with fractions. Not that that's bad, but, you know, to get x in terms of y makes it a little bit easier. So what did we do? From the first equation, we add 3y to both sides, and we get x equals -1 plus 3y. So x equals -1 plus 3y, okay? So what do I do next? Well, we know what x is in terms of y. So we substitute, right? We get 2x minus 3y, right? We substitute into the second equation. We have 2x minus 3y is 2 times -1 plus 3y minus 3y. Okay, that's what we did. And then we get -2, and then when you distribute, you get -2 plus 6y, which is -2 plus 3y. Now, this was the second equation, so this is all equal to 7. So we have to solve this equation now. We solve it for y. And as you can see, what do? We can add 2 to both sides. 3y we get then is 9. Well, if 3y happens to be 9, we just divide by 3 both sides to get y equals 3. And again, you want to get both variables, so once you know what y is, you can easily get x. Namely, you get x equals -1 plus 3y, but y is 3, so we get -1 plus 3 times 3, which is -1 plus 9, which is 8. So 8, 3 is the unique solution. This system is consistent. And if you graphed it, you would get a graph something like this. Hopefully you can see from here it's 8, 3. You can graph it in Desmos. All right. All right. How many? Do you have any questions on this? Okay. The other method for solving, the third method for us, would be elimination. There, the idea is you want to somehow manipulate the equations and combine the equations somehow to eliminate a variable. Essentially, what you want to do is this. The first step is to adjust the coefficients. You'll see that sometimes you have to multiply one or both of the equations by some number, by numbers, that is, excuse me, in order to get the coefficients of one of the variables, either x or y, negatives of each other. So equal but opposite in sign. Sometimes you can manipulate the equation so that the coefficients of x would be like 2 and -2, or 4 and -4, or instead of x for y. Then you add the equations together. What happens when you add them? You kill off the variable. You kill off the variable. All right. And then, of course, once you do that, you'll end up with one equation in one variable, right? And then it's just like substitution. You essentially solve it. Then whatever you get, you have to substitute into one of the original equations in order to get the other variable. Then you write your solution as an ordered pair because you got x and y, and then it's good to check your results. Let's try this method out. So for instance, let's look at these two. Now at first it looks like, if you were just to add them, nothing would happen, right? Because the coefficients are not opposite in signs. That is, here we have 3, but we have -4y. We have 2x, and this is 3x. So if you just added them, you would not kill off a variable. But notice what I can do is this. I can take the first equation, and multiply it by 4. Take the second equation and multiply it by 3. And now what is that going to do? Well, for the first equation, both sides I multiply by 4. So I would get 8x plus 12y equals 84. Second equation would become 9x minus 12y equals 69. But now we have these equations. Now, if I were to add these two, what's going to happen? The y variable goes bye-bye. It's gone. Right? You add them, you get 17x equals 153. Okay, so again, what we did was we manipulated the coefficients by multiplying. We saw now that one of the variables, right, the coefficients are opposite in sign. So they're the same, right, 12, but they're opposite in sign. We added, the variable is gone. We only have one variable here. We get 17x is 153. So let's solve for x. Divide, you get x is 9. Now we know what x is. What we can do is go back to one of the original equations, the ones you started with, replace x by 9 and figure out what y is. So I chose the first one. Right? When x is 9, you get 2 times 9 plus 3 times y is 21. So you have 18 plus 3y is 21. What do? We subtract 18 from both sides. And we get 3y equals 3. And then you divide by 3, you get y is 1. So 9, so the only solution is the ordered pair 9, 1. So that's what we get. Wait, sorry, went too fast. Okay. Now, was that the only way to solve this using elimination? That is, was the only way to solve this was multiply the first equation by 4 and the second equation by this? No, it wasn't. For instance, here I actually show you a sort of another way. What I can do is this. I could take the first equation, multiply that by 3, take the second equation, multiply it by -2, because then what will you get? You'll have the first equation will become, you multiply by 3, 6x plus 9y equals 63. Negative, then if you do the second equation by -2, we have -6x plus 8y is -46. Multiply the second one by -2. Now, why does that do? Well, now the equations become this, but notice now if I were to add, the x's would go away. And that's okay. Right? The x's are now gone. We're left with 17y equals 17. And of course, solving for y, you divide by 17, you get y is 1. And then it's the same thing. You plug y in to one of the two original equations to figure out what x is. So I plugged it into the first one. You get 2x plus 3 equals 21. You subtract 3 from both sides. We get 2x equals 18. Okay? Divide both sides by 2. You get x is 9. That's what we get. Oh, wait, sorry. Are there any questions on this one?